Hey everyone, now that we understand how to evaluate expressions with radicals that have both even and odd index, now we got to talk about the algebra. What happens if the radicand is not a number, but it's an algebra expression? So again, we're going to be mostly dealing with square roots and cube roots, which means we got to know what numbers are perfect squares, what numbers are perfect cubes. Well, now that we want to do algebra, we want to know what variables are perfect squares and what variables are perfect cubes. We've already discussed this before in previous modules when we were doing factoring. Remember when we did factoring of perfect squares and factoring of perfect cubes? We talked about this, so we're going to talk about it again. So the definition is, to be a perfect square, you must be a term times itself. So for a variable to be a perfect square would be an example such as x times x. X times x is x squared. Or x squared times x squared, which would be x to the fourth. Or x cubed times x cubed, which would be x to the sixth. So we saw previously, for a variable to be the perfect square, it would have an even exponent. So any variable that has an even exponent is a perfect square, which means you can undo it by doing the square root. So if I wanted to do the square root of x squared, I'm asking you what letter times itself would give us x squared? And you would all say x. So the square root of x squared is x. If I asked you the square root of x to the fourth, I'm asking you what term times itself would give us x to the fourth? And that would be x squared. What I want you to notice is there's a pattern going on when you do a square root of a variable. If you look at the original exponent, say we're doing again the square root of x squared. The exponent right now is a 2. Well, when you did the square root of x squared, you got out x. And x is understood to have an exponent of 1. Well, what happened is you really took the original exponent and cut it in half. Or you divided it by 2. So everybody look at that. If I have the square root of x squared, and I take that exponent 2 and I divide it by 2, I would get an exponent of 1. Look at my next expression. Again, I had the square root of x to the fourth. What's the exponent? 4. Square root means to cut that exponent in half, to divide it by 2. What's 4 divided by 2? That's right, it's 2. So the square root of x to the fourth is x squared. So that's your shortcut. So if I give you the expression square root of x to the 10th that's in your PowerPoint, there's no work. X to the 10th is a perfect square. It has an even exponent. The exponent's 10. So to get the square root of that term, you take the exponent and you cut it in half. You divide it by 2. What's 10 divided by 2, everybody? That's 5. So the square root of x to the 10th would be x to the 5th. Now, not only does it work with square roots, it works with cube roots. If you recall, the only term you can cube root is a term that's a perfect cube. And we went through our list of perfect cube numbers, but now we got to recall what makes a variable a perfect cube. Well, your first perfect cube was x cubed, because x cubed is formed by multiplying x times x times x. You're multiplying the same variable 3 times. Your next perfect cube is formed by taking x squared and multiplying it 3 times. So x squared times x squared times x squared, that's right, is x to the 6th. Because remember, when you multiply variables, you add your exponents. So we learned if a term is a perfect cube, the exponents are not even, because we just got x cubed, the exponent was 3. And we just got x to the 6th. The exponent was 6. So they're both not even. They're both not odd. 3 and 6 are multiples of 3. So if you remember back in factoring, we know a term is a perfect cube if its exponent is a multiple of 3. Therefore, if the term is a perfect cube, we can undo it by cube rooting it. So if you look at your PowerPoint, the cube root of x cubed is x, because if I take x and multiply it 3 times, I'll get my radicand x cubed. The cube root of x to the sixth is x squared. Because if I take x squared and multiply it to x squared and multiply it to x squared, I'll get back to x to the sixth. Now what I want you to see is a pattern. There's a quick way to do a cube root of a variable. What you're really doing is taking that original exponent and dividing it by 3. So if you look, if I have the cube root of x cubed, if I take my exponent 3 and divide it by 3, I'll get my new exponent's 1. When I do the cube root of x to the sixth, I take that exponent 6, divide it by 3, I get my new exponent x squared. And that pattern doesn't just work for square roots or cube roots, it works for any root. So the rule of thumb is to evaluate an expression using a root, and you're dealing with the term that's a variable, the rule is you divide the exponent of the variable by the index. All right, let's try some examples on the whiteboard.